You want to find out the angular displacement for theta. So very first thing is that you construct x-axis and y-axis. So construct y-axis. Now this force. Now very first thing is that this one is theta. So is the alternate angle is also theta. Now check your force. Is this force is horizontal force? Is this force is horizontal? So you have to show same distance, horizontal distance, and mark this distance as x if you are horizontal, and mark this distance as y if you are vertical. You can understand what is xb. Is it an adjacent side of theta? So is it 2 cos of theta? So first point is over. Now there is no point showing in y direction, because if I show y direction, then is the angle between y and this one is 90, and cos of 90 is what? 0. So we will not show it. Now come to this force. For this force is acting is what? Downward. So only for this case y is effective. Is here. All distance are marked with reference to origin, and they started with this one. So no arrowhead here. We are going this side. Arrowhead on one side only. This one is y, so we mark as y, and my point is a, so my suffix is a. Now this angle is theta, this angle is theta, so is this angle is theta. So right, at B, we have P1, P1 is force. Don't write plus minus, but do show their direction. Don't write plus minus, but show their direction. And see, if it is horizontal, always make x. Horizontal at point this is B. If you show horizontal, you must show x. X at what point? B point. So what is xb from this right angle triangle? Is 2 cos theta. Now see this one. Is this in the first quadrant? For first quadrant, what is the direction of x? For first quadrant, what is the direction of x? Positive. That is right word. But do not write plus minus. Go by arrow. And then partial differentiate this, because in virtual work we required very small displacement. So what is the partial derivative of 2 cos theta? Minus 2 sin theta into del theta. That is partial derivative. Step clear? Then now check another force. We have force at A. So write A. Then write P2. What is P2? 2000. So their arrow. Is it downward? If it is downward, means I have to write Y. Y at which point? A point. What is y a from this figure? Is it opposite side? So is it 3 sin theta? Now check your point A. Is it in the third quadrant? Point A in the third quadrant. In the third quadrant, y is what? Downward. Don't write plus minus. What is the partial derivative of this? Is it 3 cos theta into del theta? Any other force? No. Apply principle of virtual work. Check this direction, same direction. So first you have to write down P1 delta xb. P1 delta xb. Second one, downward, downward. Downward, downward is same. So this one is P2 delta y. Substitute. So what you are getting is minus 8000. Is 6000 cos theta. So you can very well generate tan theta. Tan theta is 6000 by this one is 3 by 4. So theta is 36.86. Here A structure with a pin connected member is as shown in figure. We want to find out the value of angle theta for equilibrium using the principle of virtual work. Neglect friction and weight of the members. So here A is fixed joint as well as D is also fixed joint. So we can have axis system at point A. Now we have shown two forces. One force is vertical, so I required y coordinate for this. This y coordinate distance is same as this distance. That is this distance. Is it a right angle triangle? And what is the hypotenuse? Is 60. Is it sin theta? So here y coordinate is 60 sin theta. The force for this one, this is horizontal force. So do you require horizontal distance? If you project here, is it consist of AD plus this distance? And what is this distance? This angle is theta. So this angle is also equal to what? Theta. So this one is 120 cos theta. This distance from here to here is basically fixed distance AD plus 120 cos of theta. This distance is AD and this one is what? 120 cos theta. Out of that, AD is variable or this distance is variable. Only cos theta will variable, whereas this distance is fixed. So how many forces? Two forces. So let's say point E. At point E, we have a force P1. P1 is W. Downward. Downward means y distance. Y distance at what point? E point. What is y coordinate of E point? Is 60. Is this point E into the second quadrant? So second quadrant is like this. Point E, second quadrant is upward. So what is delta y? Is 60 cos theta. Point we have at F. Force is P2. Is W by 4. W by 4 is leftward. Leftward is horizontal. So I required horizontal distance XF. What is the horizontal distance of XF? Is AD plus 120 cos theta. Where is point F? Is the point F is in the first quadrant. For first quadrant, X is this. X is rightward. What is the derivative of this term? What is the derivative of constant term? 0. What is the derivative of 120 cos theta? Minus 120 sin theta into negative. Now you can apply principle of virtual work. This one is downward, this one is upward, opposite combination. Opposite is negative. This one is leftward, this one is rightward, this one is opposite combination. Substitute. So if you substitute like this, your del theta is cancelled. Your W is cancelled. This 4 and this will become 30. If this become 30, this will become 2. This is minus cos 2 theta and this is plus. So this one is 2 cos theta equal to sin theta equals to 2. So theta equal to 63.43. In this question you have to find out the value of F, this value of F, to hold the frame in equilibrium under the action of force P. We are applying a force here and all these are hinges. This is hinge. This has to go to this side. The length of each link is 2a. The length of each link from A to E is 2a. B to D is 2a. D to H is 2a. E to G is 2h. 2a. And he has not given any weight of this one. So I have only considered these two forces and we assume the members are massless. Now here also this point is fixed and this point is fixed. So what we do is that we will fix up axis system at this point. From figure it looks like that midpoint. So this length is A, this length is also A, this one is A. So all members has same length. If you have multiple points, it is better to go by the graph system. So we will show this distance. This angle is theta. So is the alternate angle is also theta. If the alternate angle is theta, then is the opposite side from here to here is sin theta. And this distance from here to here is A cos theta. Now it looks like this triangle and this triangle is same triangle. So this is also theta. If this one is theta, this also equals to what? A sin theta. So all vertical distance here are A sin theta. And what is this distance? This distance is what? A cos theta. So this also equals to what? A cos theta. This one is A cos theta. A cos theta. Is it equals to 2A cos theta? First of all, we'll go for point C. At point C, I have P1 equal to P is downward. Downward means I require Y coordinate of C. What is Y coordinate of C? Origin is here. I want this distance. This distance is A sin theta. Quadrant number 4. In quadrant number 4, Y is downward. What is delta YC? A cos theta into L theta. We have a second force at G. That force is P2. P2 is the force F. F force at G is shown leftward. For this I required horizontal, so I required X distance. X distance for G. What is the X coordinate of point G? So X coordinate of point G, if the point is lying on Y axis, its X coordinate is always equals to 0. Next point is H. This time I have third force P3. This force P3 is F, but shown rightward. For this I require distance X because horizontal of point H. This is my origin at point A. From this point, this distance is 2A cos theta. The point H is in the third quadrant. X is rightward. So X is rightward. So what is the derivative of XH? Is minus of 2A sin theta into del theta. Now apply principle of virtual work. This and this, they are acting in the same direction. So this quantity is positive. This and this is zero combination, so we will not write it. This and this is same direction, so positive. So if you substitute like this, your del theta will cancel out. Your A will cancel out. And recall that theta was given as 45. And cos 45 is same as sin 45. So you left with P. Minus minus, this one is plus. So this is minus of 2 times of F equals to 0. So F is equals to P divided by 2. You want to find out P or you want to find out F? F. So is half of it. If you check this mechanism is the same mechanism that we have done just now. Only thing that, what is the change? Is the number of forces are more now. And each of the length of what? 2A. So all this length equal to what? A. And this time angle is not given. Theta is not given. And we want to find out the corresponding force P for balance. So is this angle is theta, then is this angle is also theta. This one is theta. All vertical dimension is what? A sin theta. This one is what? Cos theta. So let's make the grid first. We are going to set the axis. We can set at A or you can set at B. So better. So this one is your x-axis. Vertical is a sin theta, horizontal is 2a cos theta, and our originate point A. Let's start with point C point first. So at point C, we have P1 equal to 400. 400 is shown downward. So I required y coordinate at point C. If downward or upward, you required y coordinate. Horizontal leftward, we required x coordinate. So what is the y coordinate of this point from the origin A? Is it a sin theta? Fourth quadrant, our direction is downward. What is the partial derivative of C? YC is a cos theta into del theta. I have second force at D. This force is 100. 100 is downward. Downward I required y coordinate. Y coordinate for point D. Can you tell me what is the distance of YD from A? Is it 2a sin theta? Again the fourth quadrant, so y is downward. Derivative of YD is 2a cos theta. Next point will come to the same level at E. Level of D and level of E same, is y coordinate remains same. At this point we have force P3, that is shown P. P is upward. Upward means we required y coordinate at point E. Since the level of D and level of E from A is same, its coordinate is 2a sin theta. This is lying in the fourth quadrant, so y is still downward. What is the partial derivative of YE? Is 2a cos theta del theta. Remember, for the G in the previous case and now this case I required y distance. Y distance of G exists and x distance equals to what? 0. So for G I have force P4. 75. 75 is downward. Downward I required y distance at G. How much is G below A? Is 4 times. Vertical downward. This is in the fourth quadrant, so downward. Partial derivative of this is 4a cos theta. My fifth point is at H. G and H, they are at same level. This time the fifth force is 150. 150 is shown downward. Downward means I required y at point H. Level of G and level of H is same, so I still required 4a sin theta. Remember, for point H, 2a cos theta is x coordinate. Whether you required x coordinate for this or you required y coordinate for this. Y coordinate, because this one and this one is what? 90. So it is a passive force. What is the partial derivative of YH? Is 4a cos theta. Now we can apply principle of virtual work. Total work done is 0. First combination is positive, second is positive. So third combination is negative because they are acting in opposite direction. Fourth combination is positive because both are acting downward. YG. Last combination is also positive. Now if you substitute for all this one, this quantity is coming to be constant. A cos theta, A cos theta, A cos theta, del theta is common to all. Is it correct? So I will not go on writing this. I will simply write 400 and this quantity is common. So just I will multiply by what? 1 plus 100. This one is 2a cos theta. So I will just multiply it by 2 minus P3. P3 is P. A is multiplied by 2 plus this one is plus quantity. This one is plus. This one is 75 into 4 plus 150 into 4 equal to 0. So this one is 600, 600 and 300 is 900, 900 and 200, 1100, 400 divided by say 1500 divided by this is 750.